From the beautiful South Studios of Way Happy, this is Mr. Meyer in 5.2 Properties of Parabolas. Now, parabolas come in two different forms, right? They can come in something called vertex form that would look like this, where you'd have y equals, and then some number, and then some parentheses, squared, then something thrown on the back. Or they could come in standard form that looks like this, where it's just, ax squared plus bx plus c, regular quadratic equations. So the way we handle parabolas, we handle the parabolas differently depending on which form they're in, right? So you can see that the a value, the first thing you see in the equation, if it's positive, it opens up. If it's negative, it opens down. All right, that's kind of nice. The axis of symmetry is found two different ways. If it's this form, then we just look at the h value. We kind of do the opposite of h, and that's the axis of symmetry. That's also the x value of the vertex, right? That makes sense. On the other form, we'd have to do a little formula. We have to do negative b over 2a to find out what the axis of symmetry is. And that's also the x value of the vertex. Again, makes kind of sense. In vertex form, if you want the y value, you just look on the back end there. You just look on the back to find the y value. Where in standard form, I actually have to, whatever I got for x, right, whatever I got here, I have to plug it in and figure out what the y value is, and that'll help me get the vertex. So kind of little tricks here and there on what you're going to do for each form. So let's try it. Let's try to do everything we can possibly do on these parabolas. So look at this first one. Hey, I noticed that it's vertex form. That's the left side. So I can kind of tell you some things, like I can see that it opens down. So this opens down. How did I know that? Because a is less than 0. It's negative a half. I could tell you where the axis of symmetry is, or the line of symmetry. Let's call the axis of symmetry. I can tell is x equals negative 5, which means that the vertex, and how did I know that? I just looked right here and took the opposite, right? I can even tell you the vertex right now. The vertex is the point negative 5, negative 8, right? I just look right there. Whoops. I just look right there. Negative 5, negative 8. Remember, you do the opposite of what's in parentheses. That tells you the horizontal translation. And then on the back, it tells you the vertical translation. So negative 5, negative 8. What else could I tell you? I think that's about all. Oh, the y-intercept. I could actually even find a y-intercept. And a y-intercept would be when you make x equals 0. And so remember, an intercept is always when you make the other variables 0. So I'm going to make x is 0. And what do I get there? I get, 5 squared is 25. And then cut it in half is 12 and a half. And then take it and make it negative 12 and a half. And then minus 8. I think that's like negative 20 and a half or something like that. So that's kind of gross. So there's all the different things. And even if I had to, I could graph it now. I could be like, well, look, you're going to go to negative 5, negative 8, 1, 2, 3, 4, 5, 6, 7. 5, 1, 2, 3, 4, 5, 6, 7, 8. So negative 5, negative 8 is like right here. And then I know it opens down, and I could tell you the axis of the vertex is way down here. Here's your axis of symmetry. Here's your graph, right? Done. Something as simple as that. Let's try the other one. The other one I can tell you is in standard form, right? I can tell that that's standard form because it is written as in the ax squared plus bx plus c. So it's written in that form. Maybe I'll do this, ax squared plus bx plus c. I can tell you which way it opens. I can tell you it opens up. This opens up because a is greater than 0. So it's positive, in other words. I can find the axis of symmetry. The axis of symmetry is x is equal to the opposite of b over 2a. So what is that? The opposite of b, well, b is negative 4. So the opposite of that is 4 over 2 times a is a 2. So 2 times 2. So that's 4 over 4 or 1. So x equals 1 is the axis of symmetry, which means the vertex is 1 comma something. And what is that something? Well, it depends. What do you get when you plug a 1 in, right? When I plug a 1 in, I get 2 times 1 squared minus 4 times 1 plus 5, or what is this? 2 minus 4 plus 5. 2 minus 4 is negative 2, plus 5 is 3. So that's a 3. And so I know the vertex is 1, comma 3. And last but not least, the y-intercept is really easy to find. Again, make x a 0, and you get the 0.05. And so again, I could probably graph this pretty nicely by plotting the point. Sharks just scored. That's beautiful. And I think it was Brent Burns. So to all our friends out there, the Sharks have taken a 2-1 lead over the Kings, with Brent Burns getting his first goal of the season, as this is the opening game. All right, sorry. Now we're going to go back in 0, 5, 1, 2, 3, 4, 5. There is our intercept. Our axis of symmetry is x equals 1. And our vertex is 1, 3. So it's right there. So, and I know it opens up. Now, the cool thing is I know that there's a point there. So there's also a point here, and it opens up. I can draw this parabola with pretty good skill. All right, last one on this before we ask you a question. Again, I can see that it is, I'm going to get lazy, standard form. I'm going to say it opens down. How do I know this time? Because of right there, right? That's opens down. And so now that I got that, I can also tell you where the axis of symmetry is. So it's going to be x is equal to the opposite of b over 2a, which is 2, because the opposite of negative 2 is 2, over 2 times a, which is negative 1. So this is 2 over negative 2, which is negative 1. All right, that means the vertex automatically is negative 1 comma something. And what is that? Well, this is negative 1 squared, and then make it negative, minus 2 times a negative 1 plus a 3. Oh, that's going to be tricky. That's 1, but then make it negative, so negative 1. This is plus 2 plus a 3. So that's negative 1 and 2 is going to be positive 1 plus a 3. So that means 4. So the vertex is 1, 4. The y-intercept is going to be 3. How do I know? I just put zeros in for the x's. Everything drops out. I'm left with 3. So here's my graph. I'm going to go 0, 3 is the y-intercept. Boom. The vertex is negative 1, 4. And we said it opens down, so I know it opens down. Remember, this is the axis of symmetry, which means on the other side, there's a point equal distant. And so I can go this way and this way. That's the only way it can be. And there's, again, a phenomenal looking graph. All right, let me ask you a question, and we'll be right back after this. All right, excellent work. Now let's talk about minimum and maximum values. Parabolas open up or open down. And if they open up, then there's a minimum value of that graph. And that minimum value is right there at the vertex. So the vertex is not only a vertex, it's also the lowest point of the graph. Usually the y value will be its lowest y value that ever exists on that graph. So when you talk about the range, you know the lowest point of the graph is that y value. Excuse me. When you have a parabola that opens down, that vertex then changes its mind. It is going to become a maximum point, or the highest point in the entire graph. And so again, the range would be everything below that y value that you found. So just a little heads up that if you know it opens up, you have a minimum there. If it opens down, you have a maximum. And that vertex is kind of important. So here we go. I got one last question for you. Find the maximum or minimum of this graph. So you don't know which one it is, right? Well, quickly, I can discover that this is in standard form and the a value is negative. So I know this opens down. And if this opens down, then we have a minimum. So I'm sorry, if it opens down, then we have a maximum. So I can tell you already, thus, we have a maximum. So now, if I want to find the maximum, it's no big deal. Just like finding the minimum, let's find the vertex. So the vertex is, I don't know, right? How do I find it in standard form? In vertex form, you just look at it. But in standard form, you have to do that little equation, right? X is equal to the opposite of b over 2a. That's going to get us the line of symmetry. So the opposite of b, in this case, it's a 2. So it's going to be the opposite of 2 over 2 times a, which in this case is a negative 3. So I get negative 2 over negative 6, or what most people would call 1/3. Really? Really 1/3? Thanks for that. So the vertex is 1/3. Now, why is that bad? Because remember what we have to do with that x value? We have to plug it back in. So we have -3 times 1/3 squared plus 2 times 1/3 minus 4. We need a calculator. No, we don't. We don't need a calculator. We're going to handle this on our own. 1/3 squared is easy. Square the top, square the bottom. That's 1/9, right? Times -3. So if you want to multiply that already, that's -3/9, or what most people would call -1/3. So boom, you already took care of that. Now here, you got to multiply 2 and 1/3 together. Well, that's easy. You multiply top with top and bottom with bottom. Now this has an imaginary 1 right there. So that's going to be 2/3. It's going to be positive 2/3. And then we have minus a 4. All right. That's still not as bad as it looks. -1/3 plus 2/3 is going to be 1/3, right? Because it was bigger. The 2/3 is bigger. Minus a 4. Now up to you. You can either do 1/3 minus 4 is -3 2/3, or so the answer is -3 2/3. Or if you wanted, you could have said -1/3, or sorry, positive 1/3 minus 4. Change this to thirds. So we got to multiply it by 3/3. That'd be 1/3 minus 12/3, which is -11/3. And that also happens to be, by the way, -3 2/3. So there you go. I'm going to put it as -11/3. I think that looks just prettier, but either one is acceptable. That is the vertex, or what we would call the maximum. Now, what is the domain? For parabolas, domain is always all real numbers, because think of the graph, right? This graph, by the way, it has a vertex at, what is that, -1/3 and -3 2/3. It's like right here, and it's a parabola that opens down. So as you smush this graph onto the y-axis, on the x-axis, all of these points are going to get smushed up here, and that's going to give you points everywhere. So it's all real numbers. Now, what about our good friend, the range? So the range is like, well, wait, I like to only be smushed onto the y-axis. So it gets smushed here, and all of these points here, right, goes like that. It doesn't go above this point, though. So the range is whatever that y value is. So the range is going to be whatever the y value is. So we're going to go from -infinity, because we're going to go from way down below all the way up to -11/3. Remember, we always want to put the smallest number on the left and the biggest number on the right. And that is our range. And that's it. Have a great day. Stay happy. And I'll see you tomorrow. Go Sharks.